LEDs. We know them, we love them, we use them every day. They're in every single product we have that's electronic anyway. Now here's a little circuit, although this that we can vary the PWM of, and thus can change the brightness of the LED. That's not the subject, but these ones released in the early 2000s, got them in little LED key change torches and pretty much killed the incandescent light. Well, going back to the days when I was little, remember the films Jurassic Park? Well, I absolutely loved them films when I was little, and would probably still love them if I pulled out the old videos and watched them today. And they had them ridiculously bright torches, which could light up an entire room. Well, such torches were never available to me as a kid, probably because they didn't exist outside the world of media, until these Cree LED torches came along, and I got my first one in Tesco's. Here they are in order of purchase. This one comes in a nice little carry bag, and this one I brought yesterday. We have a Tesco's unit, we have two Aldi units, and they both contain LEDs of varying capacities. So, let's point the camera at the nearest wall, close the curtains, and see how bright they are, as best as we can demonstrate it to a camera with not very good low light capabilities. So, in true fashion, we start with the Tesco's torch. We get a nice bright spot that lights up very well, and is in fact brighter than any other torch that we've ever owned in the house. Great for walking the dog, has long distance, and I can shine it pretty much to the building opposite and light up an entire room. Then we have the first Aldi torch, which is this one. It has three modes of operation: an adjustable lens, which leads to a nice focus spot for distance, but if you're just lighting up the path in front of you, you might want it in one of the wider ranges. At 50% power mode of operation, and an SOS flasher, which is kind of cool. Then we have the Big Daddy. This thing is pretty much like one of the lights I have mounted in my halogen light setup. Completely focusable to a point where you can probably shine it for about 20,000 miles ahead of you, and then light up an entire room. This is insanely bright. Ridiculous. Should we get to some technical specifications and work out exactly what levels of power these LEDs actually use? I reckon so. To the computer! Oh yeah, I forgot to mention, 50% mode of power, which I think you can see the belt multiplexing slightly on the camera. Ha! Mind you, cameras are good at picking up such artifacts. But yeah, so in typical fashion, oh whoops, wrong thing, we go to the Tesco's LED. It has a maximum power of 3.5 watts and 291 lumen, which is at 3.5 watts. So this is what will give you the full output. Now we can work out exactly what current this is, and a maximum drive current of 1 amp. So 1 amp, you get 209 lumens out of this little thing. The next one, which is in this torch from Aldi, is about double the power, 456 lumens, 5 watts, or a drive current of 1.5 amps. We've also got datasheet specifications, and the Big Daddy of LED torches has a 10 watt LED in it, which can do up to 1040 lumens max. Now this is obviously not being driven at 10 watts, with a drive current of 3 amps. However, we can find out what these torches are being driven at, and get a rough estimate of the wattage, and then from that you could theoretically work out the brightness, but I don't know the mathematical formulas. But I do know how to work out the wattage. I've got it pasted on my wall. Okay, so let's measure the currents. first we're doing the Tesco torch. I should be using ultra fresh batteries, but I don't have any. 360... let's say 370 milliamps this thing consumes. We've already got the voltages down because I know the batteries. What was it? Bloody hell, I've already forgotten. 370 milliamps. 370 milliamps. Then the smaller Aldi one, which should go straight to full power mode, which is what we want, because this thing's got 3 modes and it's got a memory state, which can be a bit of a disadvantage for measuring things like this, but hey, such is life. I'm going to assume that this point is negative. That is running at, oh god, hang on. This is very difficult to measure, this one. That's SOS mode. That's full mode. 280 milliamps, draining fast. So the batteries aren't particularly great, so these aren't going to be the best results. So it's 280 milliamps. But remember, we're using higher voltages, which also affects the end value. And last but not least, the big ass powerful Aldi torch. Which has 2 modes of operation. So, that uses 1.30 amps, we say. Oh, hang on, let it stabilise. Stabilise, god damn you. Oh, whoops. Dropped it. It's quite a bang when you drop it. 1.160 amps. 1.16 amps. So the Aldi one draws a lot more current, but then it has 3 C cells in it, so we're probably going to end up with roughly about the same sort of battery performance out of all 3 due to the varying currents and the battery types they use. So, to the piece of paper! Yes, I know this isn't the most optimum position, but that's the best I could do under the circumstance. So here we have our little table. The Tesco's one is an XPE LED. The Aldi, small Aldi one is an XTE. And the big ass Aldi one is an XML. Now as we can see, we've got the full current these things use to hit their full potential is quite a bit under, so these things aren't being driven at even half their actual output power. You know, 3 amps for full output, 1.6. So, let's work out what wattage they are actually consuming. Now this will also be included in the driver circuit, because I've got, well, it would be too awkward and finicky to measure the individual things, but 3 volts times 0.370 equals 1 1.11 watts that this unit consumes for the test go. So 4.5 times 0.280 is 1.26 watts. So this is why the Tesco's one and the small Audi one output roughly what looks to be the same brightness, because they're consuming a very similar amount of watts. They are not consuming a significant amount each other, so there's not going to be much visible to the human eye. 4.5 times 1160 equals... I've made a mistake on the calculations there, because that seems 5,220 watts is definitely an incorrect result. So we'll do that again. 4.5 times 1 point, I forgot the decimal place, 160 amps is 5.22 amps. No, watts. That's a big W we want. So this one is actually the only LED that seems to be actually being driven at half. Before we're rudely interrupted by the camera running out of memory. But yeah, you have to take into account that these are only rough values, because the forward voltages that actually go through the LEDs are not going to be 4.5 volts. They're going to be stepped down. So this value will be subject to change, because you're going to end up with the voltages and currents being shifted, and as they shift the voltage down here, they're going to be able to increase the current to the actual LED itself. I mean, for example, this LED, the XPE, has a typical voltage that goes through the LED itself of 3.1 volts. So potentially this could have a step-up converter in it. The XTE has a voltage of, does it say? There we go, 2.85 volts, so pretty much 3 volts. And the 10 watt LED, which is the XML, has a voltage of 3.1 volts, same as this little one over here. So it is subject to change, but these make a good sort of rough estimate wattage that we are getting in light output. Obviously there'll be a certain variance probably in this region that will be subject to change more than this region of the actual full number. The decimals will be subject to change. So what else can this wattage do? Well, shall we demonstrate one fun fact? Here we have a biscuit tin. You may notice that's a little distorted. Why do you think? Well, let's show you. First we take the big old 10 watt LED torch, put it inside, switch it on, and watch closely. Intrigued. Also, if you hold it on your skin, it tends to hurt. In fact, we will focus the beam to increase the rate of heat that will be generated. And you may notice it will start to change. Slowly you'll see it sort of melt out, and any resemblance of markings disappear. I don't know how it's coming up on the camera, but I can see it clearly with my eyes, so I'm assuming it's coming through on the camera as well. So this thing has the power, bearing in mind that looked like that, it now looks like that, and it's quite hot to the touch. And also, if you hold it on your skin long enough, it will actually hurt. So, an absolutely excellently powerful and bright torch. Good for walking the dog and that kind of stuff, camping, anywhere where you need a really high power torch. Because, you know, dogs tend to run off into all sorts of places and hide. These ones, they're slightly warm when you put them up to your face, but you're not going to be melting plastic with them, I'm afraid. To disappoint. The temperature change is minimal at best. But yeah, overall, rather quite interesting torches, and it's well worth picking up Cree LED torches. This one cost about 10 quid, this one 12 quid. This one was 24, but it got reduced to 17.99, so they're within the affordability range, and I'd highly recommend picking up a Cree LED torch. The more powerful the better, but this is the sort of one that's good to put in your pocket, so you've always got one with you. And you know, you might want to put one in the car as an emergency torch, because LED torches that have these little things really aren't that great. Just think, in the next few years we'll be getting LEDs which output thousands of watts of light. Man oh man. Now isn't that awesome? And we got some burning stuff. Thanks for watching. Hope you enjoyed.